Hello everyone, in this video we're going to solve the system of two equations using matrices. In here we'll see what matrices are good for. Matrices are commonly used to represent data. It's really easier working with matrices to find the answer of the problem. Okay, here we have two equations and we're gonna find the exact value for x and y which simultaneously satisfies both equations. First of all, we need to make sure our both equations are written in the standard form. This is the standard form of linear equations in two variables, where all our unknowns are on the left side and constant numbers on the right side. Okay, now we want to represent the system of equations by matrices. Okay, first of all, we need to find the matrix of coefficients of our unknowns, and in here is a sub 1, b sub 1, a sub 2, and b sub 2. So this is our matrix, and multiplied it by the matrix, the column vector matrix of our unknowns, which is x and y in here, which is gonna be equal to the column vector matrix of our constants, which is c sub 1 and c sub 2. In this method, there's a formula for finding x and y, which is equal to a fraction, and our denominator is equal to the determinant of the matrix of coefficients, which is a sub 1, b sub 1, a sub 2, and b sub 2, and numerator is equal to the deleting the first column of the matrix of coefficients. So we ignore this column and replace it by the column vector matrix of constants. So we will move it to here. So we have c sub 1, b sub 1, c sub 2, and b sub 2. And our numerator is equal to the determinant of this matrix. As you're seeing here, c sub 1, b sub 1, c sub 2, and b sub 2. Okay? And for finding y, our denominator is the same, is equal to the determinant of the matrix of coefficient, and our numerator is different. This time we will delete the second column and replace it by the column vector matrix of constants. So we have a sub 1, c sub 1, a sub 2, and c sub 2, as you're seeing here, a sub 1, c sub 1, and a sub 2, and c sub 2, and we find the determinant of this matrix, and over the determinant of the matrix of coefficients, so we easily find x and y. And here's an example, and that we have the system of two equations, and our equations are 2x plus 5y equals 7 and 3x plus y equals 1. So for finding x, we know that our denominator is equal to the matrix of coefficients, which is 2, 5, 3, and 1 here. Okay, 2, 5, 3, 1. Okay, it's correct. And our numerator is equal to the matrix of deleting the first column and moving column vector matrix of constants to here. So we are left with 7, 1, 7, 1, okay, 7, 5, 1, and 1, and we'll find the determinant of this matrix, okay, which is equal to 7 times 1 minus 5 times 1, which is 7 minus 5 equals 2. Okay, and our denominator is equal to 2 times 1 minus 5 times 3, which is gonna be 2 minus 15 equals negative 13. So overall x is gonna be 2 over negative 13, and y is equal to the denominator is equal to the determinant of the matrix of coefficients, which is 2, 5, 3, and 1, and our numerator is equal to deleting the second column and replacing it by the column vector matrix of constants, which is 7, 1, okay? Here we have 2, 7, and 3, 1. And we need to find the determinant of that, which is 2 times 1 minus 7 times 3 is 2 minus 21, which is gonna be negative 19. And our denominator 2 times 1 minus 5 times 3, 2 minus 15 equals negative 13, and overall negative 19 over negative 13, which is gonna be positive 19 over 13. Also, we can check if our answer is correct or not by substituting it to our both equations. Here we have 2 times x, which is equal to 2 over negative 13, plus 5 times y, which is equal to 19 over 13. Okay, which is gonna be negative 4 over 13 plus 95 over 13 again, and this is gonna be 91 over 13, which is 7. Okay, so it is correct. Okay, and in the second equation we have 3 times x, which is negative 2 over 13, okay, plus 1 times y, which is equal to 19 over 13, which is gonna be negative 6 over 13 plus 19 over 13 equals 13 over 13, which is overall 1, which is the correct answer. So the answer is correct.